Okay, g'day students, and welcome to our first lesson on geometric sequences. So the purpose of today's lesson is that you should be able to use recursion to generate a geometric sequence. And we're going to use the rule for the nth term using the rule here, Tn, or T sub n equals T1 times r to the power of n minus 1. So that's where Tn represents that nth term of the sequence. T1 is the first term, n is the term number, and r is the common ratio of a particular geometric sequence from the pattern of the terms in the sequence. And then we're going to use this rule to make some predictions. Okay, so if we have a look here, you can see for a money challenge, if this were an arithmetic sequence, it would be a linear graph, but you can see that this is increasing at an increasing rate. So there's a curve here, and you can see that the amount of money being saved increases each day. So you increase each dollar per day to see the account balance go up. So this is a bit more like a geometric sequence, and this is a bit of fun as well over here. Okay, so let's have a look at this sequence here. Now we've got this sequence 2, 6, 18, 54, 162, and you can see a few things going on. So the first term to the second term is multiplied by 3, and then term 2 times 3 is 18. So each time we go up a term, we're multiplying by 3. So what we are doing is getting a common ratio, and this is for a geometric sequence. So we're multiplying rather than we're adding or minusing. So remember, with an arithmetic sequence, it was a common difference, and we used D. Now we're going to use R and have a common ratio. The common ratio is found by dividing the term just in front of, just after the other one. So if we go, for example, term 4 divided by term 3, that's going to be 54 divided by 18. Now that should be the same as 18 divided by 6, or 6 divided by 2, and they all equal 3. So this is a common ratio. Now the rule is here, so the nth term is equal to the first term multiplied by the common ratio to the power of the term number minus 1. And if we look at this sequence that we had a look at, we say the next term in the sequence is equal to the current term multiplied by 3. And we noted that the first term was 2. If we have a look at the difference between arithmetic sequence, you can see a minus and a plus there, whereas we can see a multiplied by and a power to. And here's your syllabus glossary explanation. So a geometric sequence, according to your syllabus glossary, is a sequence of numbers where each term after the first is found by multiplying the previous term by a fixed non-zero number, excluding plus or negative 1, and this is called the common ratio, for example 2, 6, 18, so on. And that's what I've showed you there. So let's have an attempt at using this recursion to find a geometric sequence. So the first one we're going to have a look at is generating the first 4 terms of the following geometric sequence. So we know that Tn plus 1 equals 2Tn, so 2 times the term number, and the first term is going to be 5. So we say, well, T1 equals 5, and the common ratio is 2, so that's our common ratio. So term 2 is just going to be 2 times the term 1, so 2 times 5. And that's going to be 10. Now, term 3 is just going to be 2 times term 2. So it's going to be 2 times 10, which is 2 times 10, which is 20. And term 4, you guessed it, which is 2 times term 3, which is 2 times 20. So that will give you 40. So our sequence is going to be 5, 10, 20, and 40. Now we can also use the rule. So if we say what the term number equals the first term multiplied by the common ratio multiplied by the term number minus 1. So we said, well, that the first term in this case was 5. And where did we get that 5 from? We said this here. Term 1 was 5 and the common ratio was 2. And you can see that here we have our common ratio of 2. So we're going to apply the rule now in a different way just to find the same sequence. So term 2 is 5 times 2. So what's our 5? So that's our term 1 multiplied by a common ratio of 2 to the power of 2 minus 1. Now we've got that 2 there and minus 1 to complete that rule up here. So it's 5 times 2 to the power of 1, which is 5 times 2, which is 10. Now let's have a look at term 3. So term 3 is, it's term 1 multiplied by that common ratio. What is our common ratio over here? To the power of our term number, in this case it's 3, and then minus 1 as in here. So it's 5 times 2 squared, 2 squared is 4, so 5 times 4 is 20. Now finally let's look at term 4, and so it's got the first term multiplied by our common ratio, which is over here, and to the power of the term number minus 1, which was this bit here. So it's like saying 5 times 2 to the power of 3. Now 2 to the power of 3 is 2 times 2 times 2. 2 2s are 4, 4 2s are 8. So 5 8s are 40. So you can still do this stuff in your head, but it will get big pretty quick. And we will end up with the same sequence. So you've got 2 different ways to get the sequence there. Okay, now let's mix it up a little bit. And what I've done is I've put a common ratio, which is a fraction. So it's a half. And I'm starting off at a negative. So we've got starting off with term 4 being negative 64. And the term, what are we? The term number is going to be half. So let's have a look. So term 1 is negative 64 and the common ratio is half. Sorry, here's our common ratio, which is a half. Okay, so term 2 has got to be half of term 1. Well, half of negative 64 is negative 32. Now term 3 has got to be half of term 2, which is half of negative 32, which is negative 16. Term 4 is got to be half of term 3, which is half of negative 30, which is half of negative 16. So that's got to be negative 8. So the sequence is going to be what? Negative 64, negative 32, negative 16, and negative 8. Now let's apply that geometric sequence rule, and we'll do the same thing. So we have our common ratio of being a half, and the first term is going to be negative 64. So term 2 is got to be term 1 minus the common ratio, which is a half, to the power of that term number minus 1. So 64 multiplied by a half to the power of 1 is 64 times a half, which is negative 32. Okay, let's have a look at term 3. So we're going term 1 multiplied by our common ratio to the power of that term number minus 1. So it's going to be negative 64 times a half to the power of 2. Now a half of a half is a quarter. So that's going to be negative 16. And then let's have a look at term 4. So it's going to be the first term multiplied by our common ratio to the power of our term number minus 1. So it's negative 64 times a half to the power of 3. Now a half of a half is a quarter. A half of a quarter is an eighth. So what we're really saying is negative 64 times 1/8. And so that's going to be negative 8. And you can see that we've ended up with the same sequence. So we've got, here's our first term, here's our second, third and fourth term. If we have a look at this geometric sequences, you can see that there is indeed a curve. And so if I think about a geometric sequence, these geometric sequences are not linear. You'll see them curve. So here's a couple of curves, our first and second one. You'll notice that we started off with negative 64 on our second one. So I started off with a negative here, and we've gone that shape. Whereas if we've gone here, I start off with a positive and a whole number, and I had that shape. There's some other sort of shapes that are going to be interesting. So when the common ratio is greater than 1, what can you see happening? You can see that shape like the first one I showed you. Now, if the common ratio is between 0 and 1, you're going to see it declining. Now, if the common ratio is less than negative 1, what can we see? We're going from positive to negative, back to positive, and back to negative. Now, as the number of terms increases, so do the magnitude of these terms. And then, if the common ratio is between 0 and negative 1, the terms still alternate between positive and negative. But as the number of terms increases, the magnitude of the terms decreases. Okay, so let's have a look at the next one. We want to check whether the following sequence is geometric and then find the value of the 25th term. So let's have a look. First of all, to ensure that a sequence is geometric, you need to check for the common ratio. So remember, we're looking at our terms and we're just dividing through. So 54 divided by 18 has got to be the same as 18 divided by 6, and then 6 divided by 2. And as we did back on the beginning, we noted, yes, that this does have a common ratio of 3, and therefore it is a geometric sequence. Something interesting from the textbook I just put in there, so you can see that your textbook is still calling the first term A, and we're just explaining how we get the different functions here. And we'll look at this when we'll look at simultaneous solutions later on as well, just to remember your exponents. And then let's just have a look here. We want to say, yes, this sequence is geometric. And now let's find the value of the 25th term. So we apply the rule. So the 25th term equals the first term multiplied by the common ratio to the power of that term number minus 1. So what we're really saying is 2 times 3 to the power of 24. So this is going to be a huge number, isn't it? So we can say that the 25th term is, well, let's go 1,000, million, billion, trillion. So that's 564. What do I say? 1,000, million, billion, trillion. So 564 trillion. And yeah, that's pretty big. Okay, let's have a look at determining the rule of a geometric sequence. So what we need to do is find the first term. We'll call it T1. Your textbook will call it A, and then the common ratio, and use it for the formula to solve for the term number. Now, I'm sticking with T1 just because your syllabus has been calling it T1. So when you come to do this in assessment, I'll get you to keep it as T1. Okay, so we need to determine the rule for the following sequence and find the 10th term. So let's look at the common ratio first of all. So we're going from 66 to 11 over 6 and 11 over 36. So 11 is 1/6 of 66. And 11 over 6, well, that's 1/6, and 11 over 36 is 1/6 again. So we are dividing through by a sixth, so we have now our common ratio of 1/6, and I just did that by inspection. If you wanted to verify that in an assessment situation, you would just substitute that into that formula to verify that this is indeed a geometric sequence. Okay, once we have determined the rule, we know the first term and we know the common ratio, and now we can just substitute in to the formula. So what do we say? The 10th term is the first term multiplied by the common ratio, which is 1/6, to the power of that term number minus 1. So the 10th term is the same as saying 66 multiplied by 1/6 to the power of 9. So if I've got a fraction times fraction times fraction, I'm getting smaller and smaller than 1. So I'm going to end up with a very small decimal. In this case, the 10th term of the sequence then is, well, that's thousandths, millionths, and billionths. So 549 billionths, which is pretty small indeed. Okay, let's have a look at identifying the position of a term in a sequence. So what we want to do there is just find the first term and then the common ratio, and then we'll substitute the value of the term number to solve for n. So for the sequence 4, 12, 36, 108, well, 12 divided by 4 is 3, 36 divided by 12 is 3, 108 divided by 36 I would expect is 3. Our common ratio is 3. Our first term in this case is not 12, it should be 4, because that's it there. And let's continue with that. Okay, so what else do we need to know? We know the term 972, so we want to find what position that is. So let's substitute in what we know. So we know that the term number is this value here. So we'll sub that straight in for that one, and then it's going to be equals to the first term, which is 4. That's 4, that's our first term there, multiplied by the common ratio, is our common ratio, to the power of that term number minus 1. So what we're really saying is 972 equals 4 times 3 to the power of n minus 1. So we need to solve for n. So we need to do some inverse operations. So 972 divided by 4 will give us 3n to the power of 1. That's going to be 243 equals 3n to the power of 3 to the power of something. So all I'm going to do is go 3 times 3, well, that equals 9, times 3 equals 27. 27 times 3 I'll have to do on my calculator, and then I'm just going to keep going until I get to 243. So 243 is the same as 3 to the power of 5. Therefore, 6 minus 1 equals 5. So the position should be the 6. So 972 should be the 6th term of the sequence. Finally, we want to look at generating a geometric sequence given 2 terms. So we use simultaneous equations to solve for the first term and the common ratio. So we'll generate the first 4 terms of the sequence, whose first term is 162 and the 9th term is 13,122. And we're going to assume a positive common ratio in this case. So what do we know? We know that the term 5 is 162 and the 9th term is 13,122. So let's substitute into our formulas. So we sub in, and you'll notice a nice relationship that it's just like your exponential laws. So we can just say, remember, if I say x over 8 divided by x over 4, that's going to be x over 4. In this case, we are doing the same rule. So we're just going to note that 13,122 over 162 will equal the r to the power of 4, because these will cancel out as well. So r to the power of 4 is got to equal 81. Now we find the fourth root of 81. So 3 times 3 times 3, so 3 multiplied by itself 4 times is 81. Now that we've found r, we can substitute that into the first equation. So 162 is got to be the same as the first term multiplied by r to the power r times 3 to the power of 4. So we just do inverse operations. 162 divided by 3 to the power of 4, so 3 times 3 times 3 times 3. Well, that's got to be 81, hasn't it? So 162 divided by 81 equals 2. Therefore, the first term equals 2. Now that we've found the first term, we can generate the next 3 terms. So here's our first term. Substitute into here so here's our term 1. Here's our common ratio, and we have our sequence of 2, 6, 18 and 54. So are you able to use that rule for geometric sequencing? So remember that Tn, or the nth term of a sequence, equals the first term multiplied by the common ratio to the power of the term number minus 1. When you're done with that, please work on the mastery exercises.